So now let's look at a couple of radical problems trying to simplify. All right, we're looking underneath the radical. Now, first thing you want to do is identify your index. Since there's not one here, it's understood to be 2. So the only thing I'm interested here is perfect squares. All right, 4 is already on the outside. So I want to look in here and I want to see, is there a perfect square that will go into 60, a perfect square factor of 60? And 4 will. So I'm going to rewrite 60 as 4 times, all right, 60 divided by 4 was 15. As far as things with exponents, if you have a square root, anything that is even or a multiple of 2, that's actually a perfect square. So I'm going to leave a to the 6th as it is. B, which is actually b to the first, is smaller than 2, so there's nothing I can do with that. Now I'm ready to simplify anything I can. Here's this 4. All right, I can take this 4 out. When I pull the square root of 4 out, that becomes 2. 15 I can't take the square root of, so I'm leaving it for now. All right, a to the 6th, when you take the square root of something with an exponent, you're just dividing that exponent by your index. So 6 divided by 2 is 3. So I'm going to have a to the 3rd. And b is just going to have to stay under there. So right now, this is what it looks like. Now, let's go ahead and simplify. 4 times 2 is 8. I've got that a to the 3rd. And then the radical is just going to have to stay like it is. All right, now look at this one. This one is a cube, so we're only interested in perfect cubes. Now, when you have a negative under a radical, if you have an even exponent, you have a problem. But if you have an odd one, well, this is actually just the -1. The cube root of -1 is just -1, and we're just going to put negative because 1 times anything is itself. All right, now, as far as your exponents go, what you want is multiples of 3. Up here, we wanted multiples of 2 because we had an index of 2. Now that we have an index of 3, we want multiples of 3. So what is the largest multiple of 3 that is still smaller than 14? And that's going to be 12. All right, 14 minus 12 is 2. Because when you multiply bases, you add exponents, so 12 plus 2 is still 14. You haven't lost anything. All right, y to the 9th, I'm going to leave it like it is. Why? Because 9 is a multiple of 3. Okay, let's pull out what we can. We already pulled out the -1 when we put the negative here. All right, the cube root of x to the 12th, you're still dividing this exponent by 3. So that's going to be x to the 4th. All right, now x to the 2nd, I can't do anything with yet. Y to the 9th, I'm going to divide 9 divided by 3 and get y to the 3rd. And that x squared, let me cross that out, is just going to have to stay under there. So that's your final answer.